Hi, this is Middle School Earth Science Semester B. Today we are going to be doing a review of Unit 1, and I am Mrs. Fessel. This flipped recording will help you prepare for the Unit 1 test. To start off, we're going to talk about the atmosphere. The most abundant gas in the Earth's atmosphere is nitrogen, at 78%. As you can see from this pie chart, oxygen is about 21%, argon is 0.9%, and the rest is made up of trace elements. And the atmosphere is where our weather is, which is what this whole unit was about. The atmosphere is the layer of gases that surround our Earth. The atmosphere is broken into layers. The layer closest to the Earth is the troposphere. It has the most air pressure because all the other layers are pushing down on it. Above that is the stratosphere. The stratosphere contains the ozone layer. Above that, we have the mesosphere, which is the coldest layer. Meteors that try to enter our atmosphere burn up here. Finally, we have the next we have the thermosphere, which is the hottest. Thermo means warm or heat. It is absorbing most of the sun's heat. Finally, we have the exosphere, or the outer layer. The prefix X tells us it's the outside or the exit to the rest of the universe. It is the least dense layer of the atmosphere. Next, we have heat transfer. Heat transfer is, there are three types, and we're going to talk about radiation, convection, and then on the next slide, conduction. So radiation occurs when heat travels without the aid of fluids or solids. This is how sunlight can come to Earth because it travels through space. You feel radiation from a fire when you hold your hands near it, very similar to how we feel heat from the sun on the Earth. Next, we have convection. Convection occurs when warm air rises, taking heat with it, cools down, such as the top of a room, and cools and sinks. We've seen lots of examples of this throughout earth science. We've seen convection in the Earth's mantle, convection in the Earth's oceans, and now convection in the Earth's atmosphere. The cycling of warm and cold air or water. Conduction. Conduction is the last type of heat transfer, and it occurs through direct contact. For example, if your hand touches a hot pan. That would be conduction. The molecules are going directly from one object to another. This has to do with weather because conduction happens when the air actually touches the ground. So the air touches the ground and then that starts convection. So in this picture here, you can see all three types of heat transfer. The sun radiates heat to the Earth absorbs it, then through conduction, the Earth releases the heat into the air, and that starts convection. So all three of these work together to help create our weather. Next, we have air pressure. So air always flows from areas of high pressure to low pressure. If you imagine a lot of air molecules bunched together, they don't want to be bunched together. So some of the air molecules move to where there's fewer air molecules, where there's low pressure. It's like if a room was really crowded with people, some of the people might leave and go to another room. That would be people moving from an area of high pressure to an area of low pressure. The molecules or the people don't want to be all crowded together. So the air moves at different speeds depending on how far apart the areas of high and low pressure are. If an area of high and low pressure are far apart, such as in this first example, the air moves slowly. If you think about that would be you maybe going from one room all the way down the hallway to another room. You move slowly from one room to another. The air molecules, it takes them a long time to get from the area of high to low pressure. If the area of high and low pressure are close together, like if the rooms are connecting, the air will move quickly from high to low if they are close together. It's easy and quick for the air molecules to move from that high to low pressure zone. So the air pressure also causes different weather systems. So first we have a low pressure system. This creates cloudy, wet weather. That's because when the air doesn't have very much pressure, low pressure, it's light and it rises easily. As that air rises, the molecules condense and form clouds, and we get rainy weather because the low pressure, the air is light and rises. High pressure, the air is heavy. H high pressure, L low pressure, light. So the low pressure light rises where the high pressure heavy sinks. As that air sinks, it warms up and creates clear, dry weather. There are also various air masses contributing to different weather patterns. Three things always stay the same throughout an air mass. It's humidity, temperature, and pressure. So each of these air masses has a different humidity and temperature. For example, a maritime tropical, maritime, as you can see over here, means relating to the sea, so it is wet from being over the water, so it's humid. It is tropical, which means it's warm. So we have warm, humid air mass here. The opposite would be a continental polar. Continental means it's over land, and polar means it's relating to the South or North Pole, which means it's cold. So a continental polar air mass would be dry and cold. So each of these words tell us what type of air mass it is and what that air mass's humidity and temperature would be. Then we get fronts, which is where those air masses meet. So a front occurs where two or more different kinds of air masses meet. And there are 4 different types that we are going to talk about today. A stationary front. A stationary front does not move very quickly, which is where the word stationary comes from. A warm and cold air mass meet, but they're moving slowly or not at all, which causes it to be stationary. So this can cause rain showers for several days because these two air masses are just sitting next to each other. The warm air is slowly rising and creating drizzly, rainy weather. Next, we have a warm front. A warm air mass actually catches up to a cold air mass. As you can see where the arrows are pointing, the front is moving this way. So the warm air mass pushes the cold air mass out of the way. We get warm weather because the warm air is pushing the cold air away. There also will be rain because as the warm air pushes the cold air away, the warm air is rising and creating clouds. Next, and finally, we have an occluded front. So this is where 3 air masses meet. So the air mass is also moving to the right, and you can see that there's 2 cold air masses and 1 warm air mass. The cold air masses push the warm air up in between the 2 cold air masses, and this also creates clouds and rain. As you can see, there will almost always be cloudy, probably rainy weather at a front because air masses are meeting. Lastly, we have the cold front. Cold fronts produce the most violent type of weather because a cold, usually fast-moving air mass pushes in and really quickly forces up a warm, less dense air mass. Because this happens so quickly, we get thunderstorms, big clouds, and this is what also causes tornadoes, especially down the Great Plains region of the United States. So this unit was all about climate and weather, so it's important to know the difference between climate and weather. Climate is the long-term pattern of weather over time for a particular area. So this is generally what is the weather going to be like in an area. Is it generally warm and humid, or is it generally cold and dry? In a place where it's cold and dry, there might be an occasional warm and humid day, but generally the climate of an area is what the general weather is like. Weather, on the other hand, is the day-to-day conditions of an area. So the weather is, if you look outside, that's what the weather is. The current temperature, air direction and speed, air pressure, relative humidity, and precipitation. Weather over a long period of time is what creates an area's climate. So some examples of climate are, if you're next to a cool ocean breeze, you're going to have a cool climate, like those maritime polar air masses. A lot of times, another example would be places next to the ocean carry moisture and create a rainy, foggy climate. Example of this would be Seattle, Washington. Those ocean winds carry moisture and create that rainy, foggy climate that Seattle knows. Latitude is also related to climate. If you see down here at about 25 degrees, for example, the tip of Florida, the lower the latitude, the warmer the climate generally is going to be. If you look up here near Maine at 45 degrees latitude, the higher the latitude a place is at, the colder the climate is going to be. So latitude directly relates to climate as well. So latitude is what causes the climate difference between, example, New York and Florida. or Maine and Florida. A higher latitude at 45 degrees is going to create a colder climate than a warmer latitude at 25 degrees. That's because those lower latitudes get more sunlight. One last example of climate, the Gulf Stream, which is a warm air and water current moving up from the equator in Tropic of Cancer, is what creates a warm climate in Northern Europe. Up here in the British Isles would normally be very cold year-round. If you look up here, the same spot in Canada is cold and frigid year-round. The reason that England has a warmer climate is because the Gulf Stream brings warm air and water to Northern Europe. That is the end of this flipped lesson. I hope you'll join me for the flipped follow-up to study for the Unit 1 test. Thank you and have a great day.